Hello everyone, I'm Dr. Luay Hanoudi and I'm working on a number of researches at the Department of Design Engineering and Mathematics at Middlesex University in London. I'm going to share some of my researches that I have finished and also these that I'm still working on. Some of these researches focus on the design concept of the multi-angled facade system. This facade concept aims to improve and optimize indoor climate and energy performance and to create architectural quality when renovating office buildings and also as a facade component for new buildings. The concept of a multi-angled facade system is based on proposing the use of two different orientations of windows in each facade on a vertical axis right and left, but not tilted up and down. The large part of the multi-angled facade is oriented more to the north and the small part is more to the south, as shown in the figure to the left. This configuration, combined with the correct use of glass properties and solar shading control systems, will help to optimize the use of daylight and solar radiation through the facade and avoid overheating problems. The figure to the right present the shading control systems of the facade, which depends on operative temperature on the part oriented more to the south and solar radiation intensity on the part oriented more to the north. The next step is starting the design of the multi-angled facade system through the creation of basic configurations of the facade. 13 scenarios were simulated for the flat facade and the multi-angled facade in different configurations and orientations by the software EDIs. The result revealed that there are more energy saving with the renovation with a multi-angled facade compared to a flat facade as seen in the diagram at the bottom right. And scenario 5D has the optimal configuration. So this slide shows a comparison between the renovation of a flat facade and a multi-angled facade oriented toward the west. The table at the right presents the energy gains and losses throughout the windows in the different months of the year. The sum of the energy gains as a percentage of the sum of the energy losses through the windows in the first 3 months of the year is 74% in scenario 5D and 60% in scenario 2A. Therefore, the primary energy consumption for heating is lower in scenario 5D by 1.8 kilowatt-hour per square meter per year. The total area-weighted primary energy consumption for lighting is lower in scenario 5D compared to scenario 2A by 1.6 kilowatt-hour per square meter per year. As a result, for the above information, there is large saving in the area-weighted primary energy consumption of about 6.3 kilowatt-hour per square meter per year when renovating with a multi-angled facade compared to a flat facade, as shown in the figure at the bottom left. In order to evaluate the visual potential of the multi-angled facade system, 4 scenarios were defined. The shading device in scenario 1 and on the large window in scenario 2, 3, and 4 is closed when the solar radiation intensity is 250 watt per square meter. The shading device on the small window in scenario 2 and 3 is closed when the operative temperature reaches 24 degrees and 25 degrees respectively, and when the solar radiation intensity is 250 watt per square meter in scenario 4. The figure to the left shows the 4 scenarios in which the shading devices are closed on a day in the middle of July. It can be observed that the length of the time for which the shading device is totally closed in scenario 1 with a flat facade is double than in scenario 2 with a multi-angled facade. The table to the right shows the impact of shading devices on the energy consumption for heating and mechanical ventilation. As a result, the shading control system applied in scenario 4 has a better visual quality, whereas the shading control system applied in scenario 2 has a better impact on energy consumption and indoor climate of the building. This slide presents daylight simulations inside the office room. The median daylight factor for an office room renovated with a multi-angled facade is 4.3%, which is the same as the daylight factor for an office room renovated with a flat facade and fulfill the Danish building regulations as shown in the figure at the top left. When the solar shading is shut down on the small south part of the room facade as shown in the figure to the top right, the average illuminance at the two working areas close to the large window and close to the small window of the office room are higher than 500 lux and do not need support from electrical lighting. According to the figure at the bottom right, the spatial daylight autonomy 350% of occupied hours to the left and annual solar exposure 1,250 occupied hours per year to the right indicates, according to LEED certificate, that there is a good amount of daylight and there are no glare problems inside the room. In order to evaluate the impact of the configuration optimization of the multi-angled facade system on the energy consumption, 9 scenarios were defined as shown in the figure to the left. The second group of simulation consists of 3 scenarios, B1 to B3, by changing the window to wall ratio on these scenarios as shown in the figure to the right. According to the calculation shown in the two tables at the bottom and in the center, 2 scenarios from the first group are recommended as optimized configurations for this facade concept. A3 for optimal daylight penetration and A7 for optimal energy performance. Regarding the second group of scenarios, B1 is for optimal daylight penetration and B3 for optimal energy performance are recommended as optimized configurations for this facade concept. In order to make a comparison between the impacts of glass properties, 5 scenarios were defined as shown at the table at the top left. The window glass types in the large part of the facades were the same in scenario 1, 3 and 5, while glass types in the small parts are different. Moreover, the window glass types in the small parts of the facade were same in scenario 1, 2 and 4, while the glass types in the large parts are different. According to the evaluation of the energy consumption, indoor climate and illuminance in the 3 tables to the right, glass type in scenario 1 is recommended due to the better illuminance provided in addition to the lower total yearly energy consumption and an acceptance number of overheating hours inside the office room. The method for investigating the potential of the multi-angled facade system in improving natural ventilation was conducted in 3 main steps as shown in the figure at the top left. The first, the intake and outtake area, were designed depending on formulas from SBI Directive 202 from the State Building Research Institute, as shown in the table at the top right. The results of the energy consumption were calculated by the software EDAIs, as shown in the table at the bottom right. The simulations of air flow through the office room and inside it, along with the room temperature and air velocity, were conducted by the Autodesk software CFD. As a result, the naturally ventilated multi-angled facade rooms save about 12% of the total area-weighted consumed energy compared with natural ventilated flat facade room, as shown in the table at the bottom right. At the top is an evaluation of the average amount of heat removed by natural ventilation. In July, the average amount of heat removed inside the multi-angled facade room by natural ventilation is approximately 31% higher than the heat removed by natural ventilation inside the flat facade room, as shown in the table at the top right. The ventilation openings with two different orientations in the multi-angled facade MAF1 improved natural ventilation better than the other scenarios. According to CFD simulations below, the room temperature was higher in the naturally ventilated flat facade room compared with the naturally ventilated multi-angled room at 3 levels. According to the type of the structural system of this building, it's possible to fix the multi-angled facade system on the bearing structure of the buildings. There are different possibilities for connecting them together, as shown in these 4 scenarios. First, column might help if needed to bear the load of a multi-angled facade on one side, and the other side can be fixed to the bearing structure of the facade. 2. Scenario 2, the slab of the new facade overlaps the old slab above it or below it and is fixed with heavy bolts so it works as a cantilever. 3. Adhesive anchors can be used to fix the new facade element to the columns of the old facade. There is no differences in the floor levels, and having a flat floor with no steps in the most cases be the only acceptable solution. And in scenario 4, a steel frame is fixed on the columns and the slab of the room to create a new floor above the old floor. In order to evaluate the economic aspects of using multi-angled facade system, the net present value model is used, which takes into consideration the following costs. First, the cost of the renovation. Second, the cost of energy consumption through the lifetime of the building. 3, the increased yearly rent after the renovation with the multi-angled facade system. The 3 green tables present calculations of these costs. The net present value for the renovation with a flat facade is higher with about 148% to 1,200% for the different real interest values, compared with the net present value of these costs for the renovation with the multi-angled facade, as shown in the tables at the bottom left. The embodied energy analysis for the multi-angled facade and the flat facade include the following values. First, the embodied energy related to the facade components or materials through the different phases of the life cycle of the facade component. Second, the total energy consumption through the lifetime of the building. The calculations of these two energy values shown in the two tables to the right. The result shows that the area weighted of the sum of the total energy consumption through the lifetime of the building and the embodied energy is higher when renovation is with a flat facade by about 11% compared with the renovation with a multi-angled facade as shown in the figure to the left. One of the main features of building facade renovated with a multi-angled facade unit is the repetition of these units both horizontally on the same floor and vertically across a number of floors, which established a kind of rhythm. This composition of the facade units can be enhanced by implementing different facade cladding concepts such as expressing contrast, harmony between the two parts of the multi-angled facade. The Sustainable Development Goals that are aligned with implementing the multi-angled facade strategy are Goal 3 by promoting the well-being of all employees in the office room, Goal 9 by improving an innovative design concept for building facade, Goal 11 by providing sustainable facade solutions through the reduction of energy consumption of the building, Goal 12 by reducing the energy consumption of the buildings, Goal 13 by minimizing CO2 and other greenhouse gas emissions. 9 publications have been produced, 3 conference and 6 journal papers. Thank you, and please feel free to contact me at this email.